Alright, we're doing a gravitation problem again. If the radius of a planet is 5,500 kilometers and an object weighs 850 newtons on the surface, what is its weight when it is located at 19 kilometers above the surface? So the first thing we want to do is we want to find the object's mass. And it tells us that the gravity is 15 meters per second squared. So we just use this equation, force weight equals mass times gravity. 850 is this force weight, and gravity is 15. So in order to find mass, we divide 850 by 15, and we get 56.67 kilograms. Alright, secondly, we need to find the mass of the planet. 2. And we need to use the formula G equals gm r squared. This g right here is a gravitational constant, and that equals 6.67 times 10 to the negative 11. Keeping that in mind, we're going to plug in the values that we already know. The gravity is 15. G equals 6.67 times 10 to the negative 11th. We don't know the mass. And the radius is 5,500 kilometers. So we're going to change it into meters by adding 3 zeros. And then you square that. Okay, and then we multiply 15 by this value. So 15 times whatever this value is equals 6.67 times 10 to the negative 11th m, and then to solve for m we divide, and the mass of the planet equals 6.8 times 10 to the 24 kilograms. Okay. Now that we know this, we can find the value of gravity 19 kilometers above the surface. So, what we do is we use the same formula. Gravity equals 6.67 times 10 to the negative 11th. And we know the mass of the planet now, so 6.8 times 10 to the 24th. And it's 19 kilometers above the surface. So we take the radius of the planet and then we add the distance that it is above. So this will be plus, now it's 19 kilometers, so we want to change it into meters by adding 3 zeros. And we square that. And once we solve for g, it equals 14.89 meters per second squared. But we aren't done yet because it wants to know what its weight is at this height. So in order to find force weight, we use the value of gravity, 14.89, times its mass, 56.67, and his force weight comes out to be 843.82 newtons.